welcome back to the second half of week 8. We are going to finish this week learning how to calculate the force of attraction between objects. So like you and the earth have a force of attraction between you, that is gravity, it's what keeps you on the earth, but you and your pencil also have a gravitational attraction between it. Isaac Newton, the old story goes that he was sitting under a tree, an apple fell and hit him on the head, and he realized that all objects attract all other objects. In fact, anything that has mass has gravity. So the more mass an object has, the more gravity it has. For example, the Earth is humongous. It has a mass of approximately 5.98 times 10 to the 24th. That would mean put 598, put 22 zeros behind it. It's a huge number. That's how many kilograms the size of the Earth, so it makes a huge amount of gravity. I am much smaller than the Earth, so when I create gravity, I don't create very much of it. I'm not big enough. It has such a small amount of force that you can't feel it because the mass is so much smaller than the mass of the Earth. Every object attracts every other object. You are attracted to your desk, your pencil, to the walls as you walk down the hallway. You're attracted to everything and everything is attracted to you. That force of the attraction depends on two things, your mass and the distance between the objects. Here on the surface of the Earth, gravity is negative 9.8. That's that force of attraction. It means that a falling object's speed increases by our 9.8 meters per second every second. But if you move up higher, move away from the center of the Earth and above the surface of the Earth, the acceleration due to gravity decreases. It gets smaller. So when you take off in an airplane and you're cruising along at 30,000 feet, there's actually slightly less gravity up there than there is on the surface of the Earth. We are going to learn how to calculate that gravity next week. Alright, so a couple of key things. The mass of the Earth, it is in there, 5.98 times 10 to the 24th kilograms. You can find this on your equation sheet. It is down. So we are officially on the back side. We are under gravitation and pendulums. Down here in the very bottom under Einstein's piece, we have the gravitation constant. The mass of the Earth is the very first one. So whenever you need that, it will be there for you. Newton believed that every object attracts every other object, and that force of the attraction depends on the mass and the distance between them. As you move further away from the Earth's surface, the gravity decreases. It gets smaller. So instead of it being your 9.8, it actually, if you're circling in the space station, might be more like 8.5. And then the bigger an object is, the higher the gravitational attraction. Alright, so as Newton was coming up with this, he came up with this equation right here to help us calculate the gravitational force of attraction between two objects. Okay, it is known as the universal law of gravitation. It's the gravitational attraction between two objects. Alright, as you look at the equation, the first part, F of G. F is always force. G is gravitational force. So F of G stands for gravitational force. It is measured in newtons. This G right here, capital G, it is a constant. It is the same number every single time. Every time you see capital G, it is a tiny, tiny number. It's what makes the mass and the distance proportional to the force. It is this number right here, 6.67 times 10 to the negative 11, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It would be that number right there. Alright, super small. It is a constant. Every single time you see capital G, you're going to type in this number. We're going to actually store it into your calculators here in a moment and go from there. M1 and M2 are the mass of the two different objects. You have to be in kilograms. And then R, think of it as the radius. It is the distance between the center of objects. So if you've got one object over here, there's the sun, here's the Earth. The radius would be the distance from center to center between them, and it's always in meters because it's a distance. Okay, how to store G into your calculator. And if you don't have a TI calculator, you can either Google it or you can come to Zoom and I'll help you set it up. But on the graphing calculators, the first thing that you have to do is type in the 6.67 times 10 to the negative 11. So into it, you just type 6.67, and then you hit times 10, caret button to the negative 11, and then you hit enter. Okay? From here, on the bottom left, there's an STO with an arrow button. That's the store button. So you hit that. Then up on the top left, you hit the alpha button. It's usually a different color, like blue or green. And then we want to look through the alphabet with the same color as the alpha button until you find G. For me, it's above the EE button. You do that, and then the last thing is you hit enter. That is now stored in your calculator. So instead of having to type this in every single time, all you have to do is hit alpha G, enter, and that number will pop into your calculator. All right, so anytime you want to store something, you type in the number, hit enter, store alpha, in this case it's G, and then enter, and it will be in your calculator from there on out. Okay, we are going to try an example together. All right, so calculate the gravitational force, that's F of G, that's what we're looking for, between you, M1, is 70 kilograms, and the person sitting next to you, M2, is 65 kilograms. If you are 1.2 meters apart, that would be my radius, 1.2 meters. I am going to use my equation, F of G, gravitational force, is equal to capital G, that's a constant, times M1, M2, all over my radius, and then you have to remember to square the radius. Okay, so into your calculator, you're going to hit alpha G, which is going to give you 6.67 times 10 to the negative 11. It's going to dump it in there for you. You're then going to multiply it by 70, and then you're going to multiply it by 65, and then you're going to hit enter, and then finally you're going to divide it by the radius, and you have to remember to square the radius. If you ever do anything wrong mathematically, almost always it's you forget to square your R. All right, try typing this in for me. Alpha G times 70 times 65. You can either hit enter or divide it by 1.2 squared, and you should get your gravitational force. It will come out one of two ways depending on what type of calculator you have. If you have a graphing calculator, it usually spits it back out to you in scientific notation. So it will be 2.11, and it'll have more decimals. I'm just cutting it off. And then it will say E negative 7, which means times 10 to the negative 7. Okay? Some of your calculators will just give it to you, like when I use my last stitch, here it is. When I use my little calculator here, it doesn't put it in scientific notation, it just gives it to me in number form. So then what it looks like is 2, 3, 4, 5, 6. It'll look at it in number form. Okay, these are exactly the same number. You can put it in either direction. I tend to use these for my answer key, just because it's less to type in, less zeros and stuff. So. All right, moving to the back side of your notes. These are what you are going to finish up and submit to me for your 5 points. We're going to go through a few of them together. Number 1, what is F of G? You just need to look at your front side. Hopefully you remember that F is force, G is gravitational force. And all forces are measured in newtons. Okay, what is G? 6.67 times 10 to the negative 11. It has a crazy unit. Pretty much what it's doing is the unit of it is canceling out everything else, making those distances and the masses proportional to the force. So when you look at it, it's on your equation sheet, but I also have it on the front side. It is a Newton times a meter squared over a kilogram squared. I'll never ask you to remember it, but you might have to be able to find it on your equation sheet. What 2 things does the force of gravity depend on? That gravitational attraction, 2 things. Mass, how big is an object? And distance, how far away is it? Mass and distance. Newton believed all things attract each other, and that is where he came up with the equation, the universal law of gravitation. What is R? It is the distance to the center of the object, and because it's a distance, it has to be in meters. If you increase the mass of the object, what happens to the gravitational force? The bigger you are, the more force you make. The sun is much more massive than the earth. It makes more gravity, more gravitational force. As you get further away from an object, the gravitational force decreases. So the farther away from the surface of the earth or the center of the earth that you go, the less of gravity that you'll feel. All right, which one did I want to do with you guys? Number 8 and 9 are pretty straightforward. I think we want to do number 10 together because we're going to drop down 8 and 9, you're just going to plug it in, but number 10, you have to solve for R, which is stuck on the bottom. So this is the one I wanted to help you set up. All right, number 10. Mars has a mass of 6.37 times 10 to the 23rd. That's huge. All right, so M1 equals 6.37 times 10 to the 23rd. Its moon has a mass of 9.6 times 10 to the 15th. That's going to be the object 2, so that is 9.6 times 10 to the 15th kilograms. If the gravitational force between them, so F of G, is giving me, I've been solving for it up until this point, now it's given to me, 4.6 times 10 to the 15th newtons. How far apart are they? That is R. So we are looking for, my unknown is the radius. We're looking for the distance between them from center to center. All right, here's my equation. F of G equals capital G, that's that constant, M1, M2 over R squared. All right, gravitational force was a given. It's this number right here, so I'm going to start plugging numbers in. 4.6 times 10 to the 15th. That is all equal to everything on this other side. The first part is capital G. That's that gravitation constant. If you forget, it's in your calculator. It's also on your equation sheet. 6.67 times 10 to the negative 11. Times mass 1 times mass 2. So I'm going to put both the masses in there, which means we just have a lot to type into our calculators. So 6.37 times 10 to the 23rd, also multiplied by the mass of the moon, 9.6 times 10 to the 15th, and that is all over R squared. All right, in order to solve this, the first thing that I do, multiply all those things by each other. Okay, so hit alpha G, and then hit times. Then in parentheses, you have to type in 6.67 times 10 caret 23rd. Close your parentheses, times, hit a new parentheses, 9.6 times 10 to the 15th. When you do that, you get all those numbers down to, let's see what will I have left. I'm going to go to a different color. On the left side, I still have 4.6 times 10 to the 15th. And now on the right side, when I multiply all those, I got 4.079. I had to drop out some decimals, times 10 to the 29th power, and that's over R squared. All right, how do I get R off the bottom? You cross multiply and you divide. All right, so we've got to multiply the R squared over here, then divide by the 4.6 times 10 to the 15th. So in math terms, you are going to take this number right here, divide it by this number right here. You're cross multiplying and then dividing, and that will be equal to R squared. I'm running out of room with my marker here. So when I do that, I get R squared when I divide the top number by the 4.6 times 10 to the 15th, I got 8.87 times 10 to the 13th. But that is not r, that is r squared. So my last step, I gotta square root both sides and I get r is equal to, you can write it one of two ways, 9.42 times 10 to the 6th meters, or maybe your calculator gives it to you just as a number and then I just leave all the numbers in there, 9416496 meters. You might have slightly different answers if you stop around along the way. That is okay as long as you are semi-close to one of those. All right, from here, you guys have 1, 2, 3 problems left to do. In order to work your way through, you're then going to submit this and get your 5 points. And then finally, your last step this week is to take the circular motion and gravity check. There's 16 questions, total of 8 points. Get everything submitted by midnight on Friday, and you are set and ready to go. Thank you.